light. It's pretty cool. Without light, you couldn't see anything. And in order to see something, you need light waves to come in, bounce off whatever it is you're going to look at, and then it has to travel a path and get back up in your eyes. All right? And so if you ever look at a kaleidoscope, this is kind of like a kaleidoscope. There's two mirrors, and there's lots and lots of images of a candle. All right? Well, each image of a candle is just another path that light can take to bounce off the candle and back into your eyes. And I can prove that to you by showing you with a laser pointer what the route that the light can take, what the route is that light can take. So we've dimmed the lights, you can see the effect a little bit better. If I shine a laser pointer at the candle, it glows. But I can also shine the laser pointer at any other image of the candle over on the left side. I can point the laser pointer at the image on the right side. I can point the laser pointer at one of the back left images if I can aim it just right here. I'm having problems aiming. Let's try that again. Oh, down over there we go. I can aim. I can hit it from back, and no matter what path I shine the laser pointer, as long as I'm pointing to the candle or an image of the candle, I light the candle up. Why? Because I'm always tracing one of those paths of light from the candle to my eye. I'm just tracing it in reverse with the laser pointer. Stolen the camera from the hands of the cameraman because I got to take a picture of myself in the mirror here. What we've got is we've got a three-sided mirror, right? Actually, it's just two-sided, and but it's at right angles. And the cool thing is if I spin this table here, right? If I spin this around, the mirrors move, but you can see that my reflection back in the back does not move. That is pretty cool. All right. So the really cool thing about that is if you build one of these reflectors with 3 mirrors, not just 2, no matter what direction light comes in, it will always bounce around and come back parallel to where it came from. So you can send light in and it always comes back to you. And that is useful for taillight reflectors on cars. And they've even put something like this up on the moon so they can shine a laser from the Earth to the moon, and wherever you shine it from, it always hits that little box up on the moon and sends it right back to where it came from. So you can time to see how long it takes light to go from the Earth to the moon. Pretty spiffy. I have a lit candle right here, but I don't really. All right, watch this while I pour water into the beaker. It still looks lit. How did I do it? Well, if we zoom back, you can see that there is actually a candle in front. This candle in the front was lit, and you saw the reflection of this candle off the mirror, and it looked like it was on this one. So a little bit of movie magic for you. All right, one last thing we're going to learn about mirrors today. And you may think that mirrors reflect things back to you, but they switch your left and your right. But that's sort of not really true. They reflect your front to your back. All right, now that's kind of confusing, but let's try and demonstrate. So here's my left hand, right? And in the mirror, it looks like my right hand. Right? And so you might think, oh, it's flipping my left to my right. Well, let's look at this. If I have the word car, and then I turn around and read it in the mirror, it looks like rack. All right? But that's not how it's really supposed to go, because when I turn it around, it looks funny. Watch this. If I take a transparency here, right, it says car, turn around, it says rack. Well, the mirror is reflecting it exactly the same. It says rack here too. So really, it's reflecting from its front to its back. There you go. And that's all I have to say about mirrors. Dr. Carlson coming to you live. Or am I?